Crash Course Instrumentation, Episode 8, Wrapping Up Voltage, Current, and Resistance. Welcome back to Crash Course Instrumentation. Today, we're bringing together all the essential concepts of voltage, current, and resistance we've explored. Consider this your complete summary, perfect for solidifying your understanding and preparing you for what's next in instrumentation and control. Let's dive right in with a thorough recap. Voltage, electrical potential energy. Voltage is the difference in electric potential between 2 points. Remember, voltage isn't measured at a single point. It's always the potential difference. Think of voltage as the electrical pressure or force pushing charges through a circuit. High voltage means high potential energy ready to move charges, while low voltage means less potential energy available. Voltage is measured in volts, V, and accurate voltage measurements are crucial for diagnosing and designing electrical circuits. Instruments like voltmeters measure these differences and help you analyze circuit health and efficiency. Current, the flow of charge. Current is the flow rate of electric charges through a conductor and is measured in amperes, amps, A. Imagine current like water flowing through a pipe. The greater the current, the more charge flowing per second. This flow can carry energy to devices like lights, motors, or sensors, powering all kinds of instrumentation and control systems. Understanding current is essential for safely operating equipment, ensuring you avoid overloading circuits or underpowering components. Tools like ammeters provide precise measurements, helping you manage system performance. Resistance, opposing current flow. Resistance is the measure of how much a material or component opposes the flow of electric current, measured in ohms, O. Different materials have different resistances. Conductors like copper have low resistance, allowing current to flow easily, while insulators like rubber have high resistance, restricting flow. Components called resistors intentionally add resistance, controlling current in precise ways within your instrumentation circuits. Managing resistance correctly ensures devices receive appropriate power levels, preventing damage and ensuring reliability. All these concepts come neatly together through Ohm's law. V-O-I-X-R-R. Ohm's law is fundamental for calculating voltage, current, or resistance when you know two of the values. Mastering this relationship lets you troubleshoot problems effectively and design circuits confidently. Real-world troubleshooting and visualization. Throughout this module, we've also discussed troubleshooting practical issues. Open circuits. No current flow, infinite resistance, often caused by broken wires or faulty connections. Short circuits. Very low resistance, dangerously high current, typically due to accidental wiring connections or failed components. Intermittent faults. The trickiest of all, appearing as unpredictable behavior, often resulting from loose connections, corrosion, or environmental factors like temperature and vibration. Graphing voltage and current over time is one of the best strategies for diagnosing these problems, especially intermittent faults. Oscilloscopes, data loggers, and digital multimeters with graphical functions help visualize exactly what's happening in your circuits, turning confusing data into clear visual trends. Conservation of energy and practical implications. A fundamental principle underpinning all these concepts is the conservation of energy. Energy doesn't vanish, it transforms. Electrical energy can become heat, light, motion, or chemical energy. Understanding energy transformation helps you design efficient systems, troubleshoot problems quickly, and optimize instrumentation for maximum performance and safety. What's next on Crash Course Instrumentation? Up next, we'll delve deeper into practical source-load relationships, energy conservation in real-world scenarios, like solar power systems and motors, and precise use of voltmeters and ammeters. This next series will build directly on your solid understanding of voltage, current, and resistance. Key takeaways. Voltage is potential energy difference pushing charge. Current is charge flow measured in amperes. Resistance restricts flow, measured in ohms. Ohm's law VR is foundational. Practical troubleshooting skills are essential in instrumentation. Conservation of energy guides efficient system designs. Thanks for joining us on this foundational series of Crash Course Instrumentation. Be sure to subscribe to our YouTube channel, join our active Facebook group, and explore the comprehensive ModL PDFs created by Tony R. Kuphaldt for more open-source learning. Stay tuned, stay curious, and we'll see you in the next exciting series.